Alright, so today's goal is going to build out the CRUD API, and that's going to be for our styles entity. So we're going to define the contract under the domain package, which we know is what the server will ultimately use to know what to serve and for the client to know what to hit. So we're going to create a directory here called API, and we're going to create a styles RPC file. Now we're not going to use RPC just yet, that will come later on, but let's keep this naming convention. Plus it's shorter than say contract. So here we're going to define our entity, which is going to be for a style. So we're going to say style extends and then a schema class, and here we're going to have an ID, and the ID will be export const style ID, a branded string. So brand and then style ID, and in fact this is a UID. So let's change it to be schema.uid, and let's export the type, which will be type of style ID dot type. Great. So with this we can say style ID, and then we have the name, which will be a string. And in fact, we're going to use trim here. So this will apply the transformation for us, not to be confused with trimmed, where it expects the string to already be trimmed. So this doesn't apply a transformation. And then we can say schema.nonEmpty string. And we can actually provide a message here saying name is required. And then we can also provide a max length, and for this let's simply say 100, and then name must be at most 100 characters long. And we also have the rules, if I'm not mistaken. So schema, and as we can see we have the name and then the rule, which is also a text. So rule, same thing, trim it first, then ensure it's a non-empty string. And for this one, let's be more lenient. So let's permit up to 1,000 characters. And let's add the comma here. Great. So now we're missing created at and updated at. And these are dates. So for this, we can use datetime UTC. And then same thing for updated at. And this is going to attempt to convert a string into a datetime UTC. And this is very, very important because remember, we are telling our database driver to return dates as their raw strings, not as a date object. Now you might be wondering why not keep the date? Well, that's because if you were to say datetime UTC from date, a date object isn't serializable. So if you try encoding this and sending this over the wire, it's not going to work because again, it's not serializable to JSON. So it's better to just let schema do everything for you and consume the same schema for the database. So we're actually going to use this schema here to decode our queries to the database. Great, so now let's define the actual contract, which will be an HTTP API group. So we're going to say export class and then style group, or let's just say group extends and then HTTP API group dot make, and this will be for styles, so our unique identifier. And here we're actually going to add multiple endpoints. We need the get endpoint, which is going to list everything. We need the put endpoint, which is going to upsert everything, and we need the delete. So let's start with the list one. So we can say endpoint.get and then list, and this will go at the root. And here we can say schema.array, so an array of styles. We also need the put, which is going to be an upsert, and this will be also at the root. And for the success, we'll have a style. However, we need the payload, and I'm adding this within the add. So let's move this under another add, and here we can say payload. And for that, we're going to create our schema. So upsert style payload, which is what we're going to use for the forms. and this will be extends schema.class, and this will have an ID, which is an optional ID. So let's use optional style ID, and we're going to have the name, and this will actually be this schema here, and same for the rule. But we're going to do something different. We're going to actually not add any validation here, simply a string. And the reason is because ultimately the one that will dictate the different rules are the input schemas, so the payload schemas in our case. And that's because these schemas that represent an entity should only represent the fundamental data types as they exist in the database. So we decouple our validation logic from our data access layer. So imagine you later down the road want to restrict name to only be maximum 50 characters. If you were to couple this with the actual entity, well, it becomes a burden because there may be millions of rows that have names exceeding 50 characters. So what are you going to do? Well, for that, you'd need to run expensive migrations. So my recommendation, keep the actual rules under the payload schemas. So anyway, we can now add these, so absurd style payload, and that's pretty much it. And we need the delete one. So we can add HttpApi endpoint dot delete, and this will be delete, and this will be again for the root. But here we can either add a URL params, or we can just use payload. So for this, let's say this will be a structure with a style ID, and this will succeed with void. So nothing at all, not even a true boolean or whatever, but we need to add an error, and that's for styles that do not match this ID. So for that, we can create a custom error. So we can say export class style not found error, and this extends a schema dot and then tagged error, or the identifier is style not found error. So this will be the underscore tag internally, and this will not have anything, not even a message. Let's just keep it simple, so we can add an error which will be style not found error. Now I believe we can add metadata, so annotations for the status code. Okay, I had to look up the documentation, I honestly forgot. For this we can use HttpApi schema, and here we can say annotations and then status 404. And for this, let's actually add the ID, so we can override the message. So get message, and here we can say style with ID, this.id not found. Okay, great, and this is pretty much it. Now we need the actual API, which is going to group all of our groups. So we're going to create a file called API, or maybe just an index under API, and this will export the domain API, which extends an HTTP API dot make for the main API, and then we can add groups. So this add is actually an add group, as we have learned this far, where we can say a group from styles RPC. And on second thought, let's actually rename this to be styles group. So import styles group, and let's update it. So now we can come here to our server and remove everything. And let's just have the domain API here, which we obviously need to implement, and we're good to go. However, notice this /index. So for this, let's actually rename this file to just domain API, and let's move it to the root. And that way we can get rid of this, and that's much better. So if we were to run this, as we can see, it works, no errors. Except that we're not providing this layer, so this is not going to work. But we still need the health check endpoint. So for that, we can use the HttpLayerRouter. Now I think that this is experimental, at least I think that docs state it is experimental, but hopefully the API won't change in the near term. So what we can do here is either say use, where we get access to the router, so router, and we must return an effect. So we can say router.add, and then we can say the method will be get or health, and then the actual response will be an HTTP server response.text OK. So this is one way, which will be the health router. Or the other way is to do it via a layer. So you can say effect discard and then a generator. And here we can get access to the router. So HttpLayerRouter.HttpRouter, and then we can say add and same thing. So health and then the handler. So server response dot text, and you get the health router too. So these are two different ways to do it, just so you know that you can get access to the router here. So you can say add all, prefix, etc. You can investigate that on your own, but I'll stick to the use. And so with this, we can merge the routes. So we can say const all routes is equal to layer dot merge all, and then API live with the health router. And what we get back is an API again. And then to serve it, instead of using HTTP API builder, we must use HttpLayerRouter and then .serve, and we pass in all routes. However, for the API live, we wouldn't use the HTTP API builder, but instead HttpLayerRouter, same thing, add HTTP API, then we say it's going to be for domain API, and here you can pass in some optional properties like the OpenAPI path. So you can have different OpenAPI specs depending on the different APIs that you want to serve, which will not apply for us. And that's it. Now we will get back a layer that will not succeed with anything, will fail with a server error. It will require the HTTP router, which shouldn't happen because we're providing this layer here, so we can remove this. And as we can see, it is only going to require the live implementation for the styles group. So now let's implement the handlers. So for that, under source, I'll create a directory called public, or maybe domain, to match the one that we have here. And this is just for future proofing. We may have some private routes where we need to listen from webhook events and whatnot. So in that case, we would have a private directory and collocate everything there. And here we're going to create another directory called styles. And within this one, we're going to have styles RPC live. And we're going to say export class styles RPC live extends, and then HTTP API builder, and then group. And then we need to say domain API, and then for what group? For styles. And here we get the handlers. So we must return an effect. And here we're going to say handlers dot, and then handle the list. And this will just succeed with an empty array. And then we need the handler for upsert, which is going to return styles. And are we exporting that entity? Well, let's find out. So styles, we are, and it's style again, singular. And then we can say make, and then we can pass in ID. This can be a random UID, and then the name, default style, then rule, whatever, and created add will be a string, same with updated add, and this will actually be an effect. So succeed, and finally we need the delete endpoint. So succeed with void, so we can say void. And that's it. And we're getting an error here because this is not a constructor. So we need to change this to a const. So export const, and do this instead and get rid of this. And for now, let's just yield effect.loginfo styles RPC live initialized. And right, this actually expects the decoded type. So we can say datetime dot unsafe now. And same thing for updated at. And so with this, we can now come here and provide the layer. So here for the API live layer, we can say layer.provide and then styles RPC live. And the error went away. And as we can see, it should be running just fine. And I was getting those 404 errors because I forgot I have another client listening for that SSE endpoint. But we should be able to test this now. I forgot we actually need to add a prefix to the styles group. So let's come here and for everything add a /styles prefix. So now let's create the repository. So for this under styles, I'll create an internal directory, which will have the styles repo. And for this, we're going to use a service. So styles repo extends effect.service. And here we can say this will require pglive, so we can provide it right away so that dependency doesn't leak. And then we need the actual effect, so a generator, and here we're going to get the SQL client. And for this we need the create, update, list, and delete endpoints. So these ones right here. So this is partially correct, but again, we're going to use the SQL schema module for this. So we can say const find all is equal to SQL schema dot and then find all. And this will internally add for us a schema.array. So that means we do not need to pass in a schema.array of the result type. So we can just say this will result in and then a style. And that's it. And then for the request, this will not require anything. So I believe we can just say void. And then we have the execute, where we get the request here, but again, this is void, so not necessary. And we can just say select all from styles. And this is going to handle the decoding for us. And we can add the delete. So this will be a void operation, but I'm thinking if we should maybe use single. So let's see what single does. This is going to decode the result using array at 0. Otherwise, if there are no results, then it is going to fail with a no such element exception, which is what we want. However, void will not fail with a no such element exception found because it is going to just do an as void. So it is going to basically omit the result. So let's use single for this. And here for the request, we can say style ID. And then for the result, we can say schema.void. And here we get the ID. And then we can do delete from styles where ID is equal to this ID. And as we can see, this is going to be an effect that will not succeed with anything. But this is problematic. Why? Because, again, this is going to decode the result. So it gets the first element. And if we deleted something, I believe we're going to get something back. So let's type this as unknown. And for now, let's add the find all and then the delete. And let's come back here to our PC live and then get access to the repo, which will be styles repo. And we must provide this. So layer.provide and then styles repo.default. And with this, we can now say repo.findAll. And right, this is going to propagate parser or SQL error. But in our case, my recommendation is to not expose those errors outside of the repo, because ultimately this is the one that will remap the errors for us. So for example, a no such element exception into a no style found error, and same with conflicts. It will handle everything internally. It shouldn't be exposed to the consumers. So for that, I always recommend doing a flow of find all and then an effect.orDie. And that way, this is effectively not going to fail with anything, at least for the actionable errors. But again, as with anything else, if you need to act upon these errors, then you should expose the error. It really depends on the control flow that you want. And for the delete, we get the payload here, and we can say repo.delete, and same thing. We're getting this error here, so we can flow, and then we can either map error, so we can get the error here and then check, is the error no such element exception? If so, then a new no style found error or style not found error, and we pass in the ID, which is an object. Otherwise, keep the same error. And right, we do not have the ID here because this is a flow, which is basically a lazy pipe. So we need to change this to an actual function where we must pass in the ID and then delete with a pipe. Great. So now this should work except for the error. Makes sense. So instead of a map error, I'll actually change these to catch tags. So this will be a no style found error, and then here we're going to say effect.orDie, and same for this one. And a parse error from a repository, realistically speaking, will always be a defect. I don't think there are any cases where it should be an actionable error unless the input depends on the user. So basically dynamic structures, a very specific use case. And that's it. We now have the delete, but we're getting another error saying it is going to succeed with unknown, and that's because we should mark this as void. And the other issue was using orDie here, which doesn't make sense. orDie is a combinator for effects, so we need to use effect.die. And with this, as we can see, it now succeeds with void. It will only fail with style not found error, and it will not require anything. So we're good to go. So now let's implement the create and update. So for this, we're going to do a create SQL schema dot and then single, and the result will be a style, and the request will be, here you might be tempted to use the absurd style payload, but again, that should be for the system boundary, which is already enforced via the contract. So in this case, I would suggest creating a separate schema where you can say create style input extends a schema dot class, and then here we can say name and then rule and the update style input, which will have the ID, name, and the rule. Or I guess you can also create a schema with omit. So omit from style, and then so it's the other way around, and here you would say the ID and etc. Whichever you prefer. But on second thought, I think I'll do that. So create style input is equal to a schema dot pick instead of omit. So at least we're being more explicit and we're not allowing any additional unwanted properties. So here we can say style, and I guess this is okay, data last. So we can say style dot pipe and then schema dot pick. And then we can say name and rule, and that's it. And then we can do the same for update style input, where we pick the ID, name, and rule. And we can now come here, say execute, and then insert into styles. And we can actually use SQL.insert and then we pass in the value. So we can say input, and this will handle the snake case transformations for us. So we do not need to do that. And I think this is how we can use this. There are no JS docs, but we'll find out at the runtime. And we need an update. So same thing, create. And I forgot we actually need a returning star. And here we can say execute update styles, and then set the name and the rule. But I'm not sure if there's an SQL update. There is. So I guess we can say update styles, and we can do SQL.update and then the input, which is actually the request. Let's keep that convention, and returning everything. And this will fail with a no such element exception, which same thing should be remapped. So now we can come here to update. We take in the request, which is type update style input, and then type of update style input dot type. And here we, okay, Copilot did it for us, and this looks okay except for the as void. We do not want the as void, and as we can see, it succeeds with style and fails with not found error. And for the create, we can use flow for this one, and here we can catch tags, and notice how we also get a no such element exception. However, this would be a defect if I'm not mistaken. Not sure when it wouldn't return the row, but this looks okay. But we can actually do an or die, and I think that's pretty much it. Looks okay. So now we can come here, and I'm not going to use effect.function or function and trace just yet, because we do not have any of the OpenTelemetry setup. So I want to do all of that within one single video. So let's just use our generator. And here we get access to the request, and we can check if request.payload.id. If it is present, then we can return yield repa.update. And I think we can just say request.payload. So argument of absurd style payload is not assignable because it isn't able to narrow it down. So let's destructure this, and maybe this works. Style or undefined is not assignable. Why would it be? Yeah, so same problem. It's not able to narrow down the type for us. So I guess we will have to do it manually. Payload.id name. Okay, now it works. And then we can do a create. No need for none of these, just name and rule. And we're missing style not found error. And that's because we need to update the styles group to have the absurd potentially fail with the style not found error. And now as we can see, the error went away. So everything is fully type safe end to end. Awesome. So now let's test this out. Let's see if it works. So again, make sure it is running. It is listening on port 3000, and let's do some curl commands. So let's do a get request empty array. So it works. Then what about creating a style? And as we can see, we get the created style. And if we do a get, we get the exact same style, same ID. Great. Now what about the update? So for this, I need to replace the ID here with the created one and paste it here, and then send this request, and the update failed. And if we look at the terminal logs, we got this Postgres error, syntax error at or near equals. That means that our update statement is wrong. So update styles and then update. This is going to replace the values and do the snake case transformation, but we're missing this set, right? Because it is just an abstraction over those transformations. So if I save this, then hopefully it should work. So let's do an update. And as we can see, we did get the updated entity. So if I list it all again, it works. And finally, what about the delete? Well, let's do a delete here, copy the same ID, and we got style not found error. But if we list everything, so get, we got an empty array. That means that, again, that's because the delete doesn't have a returning. So we need to say returning, and then let's just say ID. And if we repeat this, where we create this one, we get this ID, and then we do a delete for this one. It should hopefully work this time. And as we can see, we didn't get anything back, so it worked. And again, a get shows us we get an empty array. Great. So this is pretty much it. So now in the next video, I want to show you how you can integrate Kisely and how we can create our own SQL schema, but with type safety. Since Kisely is typed and it can infer the return type via code generation and whatnot, then we should be able to leverage it as much as possible for the best developer experience out there. So type safety and runtime safety. So anyway, be on the lookout for the next one, and I'll see you there. See ya.